Very good evening to all. Myself, Karthik. I am from St. Joseph College of Engineering and Technology, Tanjavur, and my teammate, Sarathi Vijayalakshmi. She is from St. Joseph College of Engineering and Technology, Tanjavur. We did here 1 month online internship at emertxe. The topic is embedded systems, and we learn lot of things and gain a knowledge about what is embedded systems and how we use the embedded system in a real time. And we did a project by using the concepts we learned in the internship. The project name is for black box. See what we learned in the project, everything from the scratch, from the beginning. First, we learn about the embedded systems. First, what is embedded system? A combination of hardware and software which is intended to do a specific task can be called as an embedded system. For examples, LED TV, fridge, car, robot, washing machine, and etc. They have a categories. First of all, standalone. For example, oven. Second one is real time. Example, fire alarm system. Network. Example, office security system. And mobile. Drone is the example for mobile, and hybrid, we choose the example as Google Car. Now see the memory. The memory component, we have two types. First one is the ROM, another one is RAM. ROM means read-only memory. There are a classification EEPROM, PPROM, and MOSPROM. And RAM, random access memory, we have two types. One DRAM and SRAM. DRAM means dynamic RAM and SRAM means static RAM. Let us see about the embedded system requirements. First of all, the requirements means the reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. When we going to design an embedded system, there have been some challenges. Efficient inputs and outputs be needed. Embedded on OS, code optimization is mostly needed. Testing and debugging, there are the major system challenges. And now, embedded system trends in development. When we need to develop a embedded system, we need the processors, memory, operating system, programming language, and development tools. Embedded system common design metrics: time to prototype, power, performance and correctness, size, NRE, maintainability and flexibility, safety, time to market, unit cost. They are the system common design metrics. Then the tools required to be installed. In the internship, we install these component system requirements as MPLAB XIDE and MPLAB XE compiler and Pixin simulator. Real-time aspects. There are three types. One hard real-time, another one is frame real-time, and third one is soft real-time. Now come to the microcontroller. What is microcontroller? An integrated circuit which is capable of being programmed to perform a specific task. The design normally has restriction on its memory size, I/O capabilities, peripheral functions, and etc. Why microprocessor and microcontroller? What is the major difference? Compared to the microprocessor, microcontroller, all components is in a single chip, less flexible, less design complexity. Why we choose microcontroller? Applications, performance, price, availability of tools, special capabilities. These are the reasons why we choose the microcontroller. microcontrollers, some important terms are needed. First one is host, a system which is used to develop the target. Now, what is target? The system which is being developed for specific application is called a target. Cross compiler, an application used to generate code for another architecture being is another architecture. This is called cross compiler. This is the fixing architecture. Here we choose the microcontroller PIC16F877A. In this board, these are the components. They are included. See the RS-232 LED buzzer, digital keyboard, SSD, matrix keypad, CLCD, ADC, temperature sensor, RTC, general purpose input and outputs. Then are the components. This is the architecture of the PIC 16F A77A. Microcontroller interfaces LED introduction. Okay, the every components we are using in the board, they are needed to interface with the microcontroller. First, we see about the LED, the simplest device used in most of the embedded application as feedback. LED means light emitting diode, so name indicates light works just like diode. Low energy consumption, longer life, small size. These are the advantages of LED. Where we are using the LED, home lighting, remote control, surveillance, display, and many more applications we are using LED. This is the diagram how we interfacing the LED to the microcontroller. Microcontroller interfaces LED circuit on board. This is the physical connections, how the LEDs are connected to the microcontroller in the board we are using. Microcontroller interface digital keypad. Though the another components we are using the digital keypad, it is the provides simple and cheap interface. Comes in different shapes and sizes. Preferable when the number of user inputs are less, mostly based on tactile switches. Some common applications for tactile switches are mobile phones, computer mouse, HMI. See the circuit on board. This is how the switches are connected in the board. These are the two triggering methods we are using the switch. Another one, first one is level triggering method, another one is edge triggering. Microcontroller interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an external or internal device requests the MPU to stop the processing, attends to the request, goes back to the processing where it is was interrupted. So in the interrupt sources, we mainly see the classification below. Interrupts classified into hardware and software. In hardware, it will further classified into non-maskable and maskable. Maskable is further classified into two external and internal. Interrupts are handling. This is the diagram shows how the interrupts are handling. Interrupt service routine ISR. It is the important similar to subroutine. Return from interrupts attends to the request of an interrupting sources. Interrupt latency. It is the time spent executing protected code, the effort to implement priority scheme. Another component is timers. Timers resolution. Here you see the resolution means register with. Tick means up count or down count. Quantum, a system clock setting. Scaling, it is two types, pre-scaling or post-scaling. The modes are counter, PWM and PW. This is the block diagram of timer 2. In timer 2 block diagram, we see the post scalar, timer to register, comparator, PR to register, and prescaler, everything. Now the another component and the main important analog to digital converter, it is called ADC. ADC means it converts the analog values into a digital values. Types of ADC, here we see there are more type of ADCs are there. First, the flash ADC, pipeline SA or dual scope sigma delta. So the analog inputs we have to see the terms step size, full scale range, acquisition time. The three diagrams are represent what they are and how they are working. Analog to digital result justification. Here we use the two types of justification. One is right justified, another one is left justified. It is the diagram represent the CLCD. The two represents the we are two lines we are using. That's why it is kind of matrix. 16 and and 2. Now inter-integrated circuits they are also called I squared C. Introduction. It is a synchronous half duplex act as a multi-master or slave. It is the connection between the two components. One is act as the master, another one is act as the slave. The bus features, let us see, two-line interface, software addressable, multi-master with CD, serial, 8-bit oriented, bidirectional with two mode, four modes, on-chipping, filtering. These are the bus features. It is the example for I squared C. Here we clearly see the microcontroller, LCD driver, EEPROM. The more are the components, they are connected by using the data or clock. Line represents the data line and the blue color line is represent the clock line. Now see the I squared C signals, two wired sub interface. We have two SDA and SCL. SDA is the D represent data. So SDA is serial data and SCL. The C represents the clock. SCL. So SCL means serial clock. Diagram we have see the condition and the data validity and I squared C signal transmission, data on SDA, clocking on SCL, clock synchronization, data abstraction. These are the process in I squared C signals transmission. Now see the data on SDA. This is the diagram represent how data on SDA. Then clocking on SCL. The clock synchronization and data process. Now a complex data transfer. The SCL SDA represented in the diagram. So bus splits, there is two types, bidirectional bus, another one is unidirectional bus. In bidirectional bus, we have seen the four modes, standard mode, fast mode plus high speed mode. The compared with the four modes, high speed mode are very fast. And now unidirectional bus, we have two modes, ultra fast mode, uses push or pull drivers. In ultra fast mode, we have seen the 4 MB per second. This is very high, comparatively high to the bidirectional bus. This is the MSSP block diagram. This is the master synchronous serial port. It is shorted by the MSB. Data EEPROM and the flash program memory. The data EEPROM and the flash program memory is readable and writable during normal operation. This memory is not directly mapped in register file space. Instead, it is directly addressed through the special function registers. The special function registers are given below. Now see the EE count 1 and EE count 2 and EE data and EE DATH and EE ADR and EE ADRH. General description: the DS1307 serial real-time clock. It is a low-power, full binary coded decimal clock or calendar pulse, 56 bytes of NBS RAM. The month date is automatically adjusted for month with fewer than 31 days. The clock operates in either 24 hours or 12 hours format with AM PM indicator. It has a separated battery power supply. Clock and calendar. The time and the calendar information is updated by reading the appropriate register bytes. Here we see the diagram. It is very useful when we are going to program a RTC. This diagram is available in the data sheets. And now the DS1307 address map. Now see the diagram: seconds, minutes, hours, day, date, month, year, control, and the RAM. We are going to see about what the output of the car black box. In the simulator, we did a code in a MPLAB XIDE, and using the compiler, we create a hex file. The name is final car black box.hex. We using the board as I said previously. The board name is PIC Juniors and the microcontroller name is PIC16F877A. Why we choose this microcontroller? Because it is the general purpose. Now see the outputs. First we go to the file. We can see the load hex. It is the our created hex file. Now see the output are coming. When we now see that CLCD and the switches and the digital keypad and the LED display. Another one is the LEDs are there and the potentiometer. When we vary the potentiometer, we can see the speed are increasing. And then the RTC, and this is the main our microcontroller. This is the EEPROM. It is used for memory, storing the events here. And this is the power supply. And we have a reset button. And we also other components like serial ports, cooler, buzzer, and etc. Now see, there are the switcher. When I using the switches, we can see the events are changing. Gears 1, 2, 3, and neutral gear G3, G4, and we use the another switch. We can see they are going back to the previous one. Now this switch used when the collision is occurred. C means collisions. Now see the event is changed to collision. Now coming to the switch, when we press the switch, it asks over the password. Now see, first we use the password wrongly. It shows that we having a two atoms remaining, and another one time again we did a mistake. It show one atom remaining. And when we using the same methods, we have only three atoms. After the three atoms, the interface is said that the user is blocked. Now see what's happening when the three atoms are fade. Now see, in display we see that you are blocked. Wait for 50 per seconds. It is it is decreasing in order by using the RTC. After that, the 60 seconds is come to the login board, like to enter your password. Now I'm enter the correct password. It shows me the login screen. In login screen, we have options like view log, clear log, and change password. First, we see the view log as using the switch number 5, switch number 6, admin, or V5. See the collision, the event is shown that after the reset, it shows the mostly occurred 10 events. And another, again, we are using to our password to go login screen and see what is clear log. Logs are cleared. Okay, if your user want to clear the logs of the events, they use the clear log. Now see, after clear log, there is no logs on the screen. Okay, then now see what is the third option in the login screen. The change password. If user wants to change his password, this option is really helpful. Now see, firstly, the user need to enter his new password and retype the same password again. If we change that, it shows the your failed. The password change is failed. Now this time we use the correct keys. Okay, password change successfully, and after that it directly go to the login screen. See the potentiometer when we change the speeds are increasing and decreasing. And RTC is really useful for the time. It is given the real time. And EEPROM is used to store the events. Okay, guys. And thank you. Thank you for this opportunity. Come from the 1 month internship from emertxe. We gained a lot of information and knowledge. By using this, we can do this. Thank you.